Hello. Okay, we're just going to keep going. Just going to keep these videos around 10 minutes. Um, so the next one is we'll talk about now conditional variance. And it's similar. We'll define it. Variance of x given y equals little y. Again, I could just leave it big Y and then it would just be terms of big Y. This is maybe a little nicer. This is just equal to e of x minus e of x given y equals little y. And this should all be squared given y equals little y. This should make sense. At least everything in here should make sense. This is the expected value of x given y equals little y. So this is a function of little y. This is a function. This is x. So this is x minus a function of little y. Big X minus a function of little y. And it makes sense to take the expectation of that with respect to little y. Okay? So if we expand this now, we get this is also equal to e. I'm skipping a step or two, but we did do this already, and I think it's good for you to see these things sometimes with steps left out that you can do. So then we have e of x given y equals little y squared, right? Okay, so from here, we have a property. We want to do an example here? I think probably not so much. We did one in class anyway. So one thing before we do this, maybe just a little baby example. So recall, just to make sure I know you all know this, if x is exponential with mean equal to theta, then e of x is theta and variance of x is theta squared. Okay, so just for our future reference, we proved this right from taking the integrals of these two. We can find this by finding that by taking the integrals. Okay, so you should do that probably. I won't do it here. All right, so we have this property. So this is practice, just trying to make it clear. I did it out here, but I think I'm going to leave it out now that I think about it. Practice, show this. It's really Math217, but okay. We have our second property, property 2. Variance of x is equal to variance of e of x given y plus e of the variance of x given y. Okay. Let's do an example with that. As an example, suppose x is exponential with mean equal theta, and theta is uniform 0, 2. Then what's the variance of x? Well, you might say the mean of theta is 1, so maybe the variance of x, I know it's theta squared. If I know theta, it's theta squared, so maybe it's just 1 squared or 1, but it's not. It has those two terms. So we'll just use the formula we have. So find variance of x. Okay, we need to find each of those terms. So we use prop 2. Variance of x equals variance e x given theta plus, I'm running out of room, I can't write over there. Variance of x given theta, which equals, what's the variance? Okay, so what is e of x given theta? Well, if the mean is theta, then e of x is theta. So e of x given theta is theta. So this is just variance of theta, the first one, plus, okay, what's the variance of x given theta? Well, x is exponential, and we wrote up there, and maybe you proved it, did it out, is theta squared. So we have plus e theta squared. Now I can use the formula that variance of, say, a random variable, let's call it something else, w, say variance of w is EW squared minus EW all squared, and to replace this e of theta squared. So this is equal to 2 variance of theta plus e of theta all squared. That's a nice substitution, saves us a little time. So now I know the variance of a uniform AB. So if, say, so we know the variance of this guy, uniform 0, 2, is 2 minus 0 squared, b minus a, all squared over 12. So I get 4 twelfths, I get 1/3. So this is 2/3. And the expected value of theta is 1. So I get 2/3 plus 1. So 5/3 is the right. It's not 1, it's more than 1, it's 5/3. Okay, let's prove that, right? The proof is not hard for this, so check my notes here. So proof. All right, so I just want to prove that the variance of x is equal to the sum of these two things, and the simplest thing to do is to just write out what these are. So we have variance of e of x given theta. This is equal to, from the second part of the definition, this is equal to the expected value of this thing all squared, right? What's the expected value of that thing all squared, e x given theta, all squared, plus, well, that's the trick, just move the paper to the left, yeah. Plus, well, it just took me a second to figure that, plus, so it's e of this all squared plus, it's e of this all squared plus e of this and that all squared. But what is e of x given theta? From property 1, it's just e of x. So this is just e of x all squared. Yeah? And it should be minus, right? Right? So it's e of this all squared, e of this all squared, minus e of this all squared. So e of this is just e of x from property 1 all squared. So that's that one. And for the other one, we have e variance of x given theta. Right? And the thing to do here is, again, expand out what variance of x given theta is. So this is e. So this is e. Variance of x given theta is e of x squared given theta. Minus e x given theta all squared, right? Yep. Okay, now I apply the expected value in here. These are functions of theta now. And when I apply it here, I get e x squared given theta. And when I apply it here, I get, oh man, what do I get? I get e of, I don't know what I get here. So I get e of x theta all squared, right? Now this one, though, is just e of x squared. So I get e of x squared. And this one, I don't know what it is minus e x given theta squared. So now I see when I have this and I add these two together, so adding these, so var e x given theta plus e var x given theta is equal to, when I add them, I get e x squared minus e x squared, and this is just variance of x. How much time? Gotta stop. We'll continue soon.